All right, give this exercise a try. So, if you are careful, you should be getting 3 times the identity here, and also 3 times the identity here, and quite magically, a 3 here. Well, no, it's not magic. It turns out to be a general fact, which we will see in this theorem here. So just as we found, okay, these 3 things are the same. Okay, here's our 3. This is our 3i here. This is our 3. This is our 3i here. Now, if the determinant is non-zero, then, as we've seen, the matrix is invertible, and we can solve this thing. You can take this equation, take this equation here. You have A, adjugate A is this guy times I. Now if I solve for A inverse, I get this equation here. All right. So this formula here, in terms of finding inverses, I recall when I was in university, I had friends who would do 3x3 matrices. They would find the inverse of a 3x3 using this formula here, and it was pretty useful for them. Okay, they became very adept at finding this adjugate, and then it was quite quick to find the inverse. In general, it's better to do the usual inverse matrix algorithm, but it has its theoretical uses. This formula certainly does. Speaking of theoretical, let's do a theoretical example that makes use of this formula. All right, this example. So, looks very abstract, but I'm actually going to be able to determine this number here because I can use the formula for the adjugate. Well, the A inverse is 1 over determinant of A times the adjugate. So I can take this equation, solve for the adjugate, and then use that. So I get determinant of A, so I'll bring this dude up here. So here's my adjugate. Can be replaced with this shman. And then I will be in business because I can factor this item in the bracket. So I can certainly factor out the A inverse. So A inverse, I factored off the right, and what's left, I get 1 plus determinant of A. You may think this should be an identity here, but no, this is a real number here. Okay, the determinant is a real number, so it makes sense for me to have the real number 1 there, not the matrix I. Okay, now I can use the fact that the determinant is 4. So I get determinant 5 A inverse, because I got 4 plus 1. And then the 5 can come out. Remember, when the 5 comes out, you have to put the exponent 2. I put a 2 because the matrix is 2 by 2. Oh my gosh. Determinant A inverse, and this is 5 squared times 1 over the determinant of A, which is 4. So I get 25 divided by that 4 there.